Welcome to Module 4, Groundwater Heat Exchangers. In the first submodule, we look into geological and hydrogeological parameters and conditions. You already know from Module 1.4 that groundwater heat exchangers, also known as groundwater heat pumps, work by using usually two wells, one to extract water, then water runs over a heat exchanger to extract the heat, and then via a second well, it is put back into the groundwater. The system also works for cooling. In that case, you put back the water with a higher temperature than you had previously extracted it. And then you can also use the two wells to actually store heat in the groundwater and extract the heated groundwater from the same well as you put it in, and by that you reverse the flow direction. Such a system would then be called an aquifer thermal energy storage. But in this module here, we deal with the groundwater heat exchangers, or sometimes also called pump and dump systems. And to run these systems efficiently, the following conditions have to be given in the groundwater. We need sufficient discharge. This affects how much water you can use, and thereby affects the amount of heat or cold that can be produced. You would need enough distance between the extraction and reinjection well to avoid a shortcut between those two wells. You need good groundwater quality, suitable groundwater temperature, and of course a good drillability so that you can actually build your wells. So these are all related to hydrogeological conditions, and that's what we will look into in more detail. Other preconditions like sufficient distance from neighboring water rights or other legal restrictions are not part of this submodule, although we will look into some of the hydrogeological restrictions. But first, before we start looking into these hydrogeological conditions in more detail, it's important for you to know that in general, there are three different types of rocks that bear the groundwater. A geologic unit containing this groundwater is called an aquifer. And the three types of aquifers are called porous, fractured, or karstic aquifer. The porous aquifers consist of loose sediments like gravel or sand. And also porous rocks like sandstone can be aquifers. Porous just means that there are many little holes in the rock or in between the pebbles and the sand grains. The holes in the porous aquifer are connected in a homogeneous way, and this is where the groundwater then flows. And these porous aquifers are the ones best suited for our open loop systems. Some fractured rocks with a dense and homogeneous distribution of the fractures can have similar laminar flow dynamics as the porous aquifers, but often the fracture distribution is inhomogeneous and turbulent flow may occur in larger fractures similar to as in the karstic aquifers. In rare cases, spring water from those fractured or karstic aquifers can still serve for the groundwater heat exchangers. But as we move on, the hydrogeological information described relates to the porous aquifers. And this submodule, we're discussing the hydrogeological data that is necessary for the planning of either individual groundwater heat exchangers, but also to assess the resources on a larger scale. So in this figure, you see a cross-section of a groundwater heat pump, and at the top view, the propagation of the thermal plumb. Also, most of the relevant hydrogeological properties that we need to describe for the design of a groundwater heat exchanger or these resource assessments are shown here. We have to know about the hydraulic conductivity, the depth to groundwater level, groundwater thickness, the groundwater gradient, the groundwater temperature, and also its chemistry. And we will look into it in more detail in the next part, so stay tuned.